Hello, guys. George here from Delusional Designs, or formerly of Delusional Designs. Uh, Today, we're going to go over a little bit of milling, milling concepts, how to set up a file, what to look for. I am not going to get into every detail and every variable about this. Feeds, speeds, the bit type, what you're cutting, your type of machine, whether you're using coolant or not, temperature, quality of the bits, um, quality of the machine. Every single thing is a factor here. I am not talking about any of that. I'm simply going to get into basic concepts on being able to cut apart, get the detail, and all of that stuff. So I have a little test file here that we're going to go ahead and cut just to show you some different things and how it works in sheetcam when you're laying it out. So as always, I've drawn my part. I've combined and differenced all of the parts that I want to come out, and here I have it. So I've brought that into sheetcam, and we can see our outer shape is red, our inner shapes are yellow. Our true circles and true shapes have a little cross in the middle, and it's got a radius that's a exact symmetrical piece will have a little cross in the middle. So we can see our nodes are white, so we can see we don't have a obscene amount of nodes here, which tends to affect you less when it comes to milling, just because of the way the bit works. Um, but we have a bunch of different ways we can do this. So this part could get just fully cut out, which is called a contour, which similar to what you're doing when you're doing plasma, you're just contour cutting all your shapes out. We can do pocket, where we actually mill in the pockets and mill them out. Okay, so that's a possibility. So we have two choices here of how we do this. Okay, uh, first one, I'm just going to show you what would happen if we just did this as if we were going to use a 1/4 inch bit and contour cut this, because our kerf of our bit really does bad things to how our stuff gets done. And we have so many different options on how to do things, and just how we do it can affect whether we successfully do this without breaking a bit or not. But I'm just going to go to contour cut. I'm going to select layer white, because right now I just have everything on layer white. I've got a 1/4 inch bit. Uh, right now I have this laid out like it's 1/4 inch thick material. So I actually am going 30 thousandths past it, and I have my material depth of 5 thousandths beyond that. So I'm going to do a cut depth of 28 thousandths. Uh, I'm doing 70 thousandths per pass at 40 inches a minute, 4 inches a minute plunge rate, and my spindle speed is 16,800. I'm also doing a climb cut. Okay, so I'm just going to go ahead and hit OK, and let's just see what this would do for us. So trying to use a 1/4 inch bit to do this file. Uh, on our outside shapes, we were going to be good until we get here. We don't have detail in these corners. We didn't get to all those. We didn't even do this because this was narrower than 1/4 inch. These slots are 200 thousandths wide. This is 126 and a 1/4 inch. So it was not even going to do a tool path for these at all. We can see in our star, our corners, we don't get into the corner because of the radius of the bit, but our inside corners we do. These here we don't get into our corner very good with a 1/4 inch bit, and this up here we don't get into this corner, don't get into these corners, and don't even touch this part with a 1/4 inch bit. So what you draw and how you draw it affects totally what bit you're going to have to run and how you're going to do things. Uh, right here, this piece is actually going to receive a piece that's a 1/2 inch by 3/4, and it's going to have square edges that goes into this hole. So if I was to cut it with a 1/4 inch bit, it would not give me a square corner for my part to slot in. Same with this. If this was going to be getting the part that's a 1/2 inch slotting in here, it would not be able to fit if it was a square edge, how that's drawn. Okay, so that's why I've just done this. I just want to go through a couple things. Right now, if I was to just mill this out, this piece here has nothing holding it in. When it gets cut, it's going to snap off and it might break our bit. Up here, same deal. Here, here, and our whole piece. When it gets done cutting, it's just going to snap out of there, and that can break a bit when it does that. So, we wouldn't necessarily want to do that, but I'm going to get into tabbing here in a little bit. First thing I want to do, I'm just going to go back into my file, into my cut path, my operation, and I'm actually going to change just down to an 1/8 inch uh, and run the parameters for 1/8 inch here. Um, Now, let's see, look at the difference here. With this, I was able to cut pretty much everything except for this little piece because it's still smaller than an 1/8 of an inch, okay? Uh, Now, you see, I still have a piece that's going to pop out of here and fly around. A piece here, piece here, piece here. And these are really particularly hard to tab. If you tab this, you're not going to get a round hole when you cut that out. It's just, you're going to have a good way to get the tabs out and still have this shape looking right. So, um, we really probably don't want to do this with a contour cut for these small shapes. It's not going to be in our best interest. Um, Now, what I did here, you see I put these little half circles lined up with our edge in this. So when it goes in, it can do an overcut. Now, if we put a square piece into here, it's going to fit, and it's going to fit totally tight. We're just going to have a little opening here and here, but there's not going to be any issues of it getting all the way in or putting a square piece into here, okay? And it still doesn't get all the way into the corners of our star, but it's going to do better, okay? So this gives us more detail. If we went with even more of a smaller bit, we would get better detail. Okay. Um, so what I'm actually going to do is I'm going to break this up into different layers to show you how it would affect things differently. Okay. Because I want to do some of these things as a contour cut, just to we've seen this. I'm actually going to go and move things to different layers so I can use a different size bit and do different strategies. Okay, because right now this would just plunge down. This one right here, particularly, is a 126 thousandths hole being done with an 1/8 inch bit. It's just going to plunge down, plunge down, plunge down. It's not going to do any retracts. But if we did this as a drilling operation, it would go down, and then pull out to get the chips out. Then go down, which is going to prevent us from breaking bits. So there's a whole bunch of things that we have to consider just in our strategies so we're not breaking bits or having problems, okay? So I'm going to go ahead and just click off this operation so it's not in my way for now. I'm going to go up to C, which is contours, okay? And I'm going to move a bunch of these to different layers that I want to do different things with. So I'm going to keep um, the star part of the original shape because I do want to do a contour cut on it. Um, These others, I'm going to pretty much do a pocket on them, but I'm going to change the size bit that I use just to show you how that affects it, okay? So I'm going to move this one to a new layer. I'm just going to call this big circle. So, cool. All right. I'm going to call this one big for rectangle. Um, and then that's got me with the big circle and the big rectangle on different layers. And you can see these turn red. So it's no longer looking at this as a separate inside piece. These are now their own entity. So it's going to be viewed different by the software. Okay. Um, so I'm just going to grab the rest of this stuff other than this small circle. I'm going to put the small circle on its own thing too. So we'll call this one small circle. Okay. So right now we've got 4 different layers here. Um, I want to make this actually where I've got 5 different layers. So I'm going to just take these guys, um, call this pockets. Okay. I'm going to put this one on pockets, this one here on pockets, this one on pockets, and this one also on pockets. Okay, so we can see we've got this is still on this layer, that one is still on that layer. I'm going to move that over to pockets as well. So this and that are on one layer, which you can always click to turn off the different layers to be able to see which piece is on what. Okay, turn it back on so you can see what you've got going. I know it sounds like a lot already, doesn't it? We really got to start thinking when we do this. It's not like uh, when we plasma cut and we have it do everything for you automatically, where it's finding the material and doing all that stuff. So I've got to be strategic on how I have this cut it out. If I had it just do the outer shape first, these pieces are not going to be attached to anything, and we're going to have a problem when it tries to mill those, right? So we got to go through strategically. I'm just going to go ahead and go to Operation Pocket. I'm actually going to pick the big hole, the big circle. I'm going to use a 1/4 inch bit because that's a little bit bigger. Okay, and I'm just doing these all the way through. I could go different depths. I'm not going to get into any of that right now. I'm just going to do it where I want to cut it out, so I end up with a contour cut for everything, where it's actually all cut out, just to demonstrate. Okay, so here we do this, we can see that made our tool path, right? Next one, I'm going to do Operation Pocket. I'm going to go ahead and let's see what other layers we got here. Um, we're going to do our uh, big rectangle, okay? And I'm just going to do this with the big bit as well, just to show you how it comes out. So we can see we still got our corners that are not very good radius, but we'll get this cut all out so we don't have any piece breaking off to break our bit, okay? We're going to Operation Pocket again. I'm going to select pockets, but this time I'm going to do it with an 1/8 inch bit. Okay, select that, and that's going to give me all of the rest of these, other than small circle and what is on our outer layer. Okay, so for this small circle, I actually want to do a drilling operation for that. So I'm going to go to Operation and Drilling. Okay, I'm going to select that small circle. Okay, I've got an 1/8 inch bit. I want to do 280 thousandths cut depth, and this will pick. It has a range, so it'll do between zero point 0.1 and 0.19 right now. And I could change these. I know I have a circle that's 0.126, so that's going to fall in that range. Okay, it's going to do 8 cuts, but it's going to go down 35 thousandths pass. But as it gets to 39.4 thousandths, it's going to actually pick back up. So it's going to retract. So here we go. We just did that. Now I'm going to go to Operation and Contour Cut. Okay. We've got our layer white selected. We've got our 1/8 inch bit. Okay. And we're doing the same depths as we did before. It's going to be 8 passes. I'm just going to hit OK. And that does our contour cut for that. But right now, this piece is going to break loose, and this is going to break loose when it cuts. So we need to go ahead and fix that. So first thing we need to do, we need to scroll down here and select the outer layer. Okay, so we've got this layer white selected. Now we're going to go to tabs. Okay, now we can just as simple just come in here and put a tab or two to hold things in. Okay, great to put these where they're easy to clean up. Use a router or with a little cutoff bit. Um, the flush cut bit works really good for this. So just put a couple tabs, right? Where you put your tabs at can be really important. Uh, if you put them in a place where they're hard to clean up, like I actually did here, because uh, I'm on that corner. I'm gonna have a hard time maintaining a good corner doing that, but I'm gonna do it anyway. If I tabbed it in here, really not gonna hold a whole bunch because that's gonna be so thin. Just get them out on the outside wherever you can. Sometimes you have to use that to hold another piece, but um, this is what we're going for. So uh, now, because this is milling and not plasma, we don't want to just go ahead and, oh, it's great, let's run it. No, we really want to go ahead and simulate this. So I've got it set to run at 1,000% override, okay? And I've got this set to milling. It's going to show me my feed rates, my spindle speed, which bit it's using, and the time and all of that. So I just hit start and I'll run this out and I can see my speed's too much for what it's doing. Is the spindle speed not right? Does that match my bit? Because it's pretty easy to get a decimal point in the wrong spot or something of that nature and end up with a great big problem, right? So, as of right now, we really screwed up, didn't we? Right? Because we can see it's not cutting the part we wanted it to do like we wanted, right? Right now, we've actually got an outside offset cut for this outer part, right? Not what we want. So we can see that's our first operation. We need to go and edit it because look, we had layer white selected, right? So this is definitely not what we wanted. We didn't even want a contour cut here. Okay, so let's just see here what we have here. Let me just delete this operation. Okay, now you still see it's all working here, right? We're going to start this again and see what it does. See, that's what we were looking for. We did our circle first, and that's what we want to see. We want to see it doing our circle and our slots, and all of this is the big rectangle we put as a layer. It's going to go right in the order that we did them, and you can see it right here. It's going to go right in the order that we did them and do them. So this will be a good indication of how long is it going to take. There's a lot of times you can save some time doing slight changes to things, or just understanding that, hey, this is going to be a 2 hour time or whatever. So you can charge accordingly. This gives you a great idea of what it's going to cut. This is actually pretty accurate here. We can also go into our job report and look at how many inches it cut and all of that stuff, how much volume we removed and whatnot, and see um, what we want to charge. So we let this run out, and you would see uh, what it does is going to be our cut file, and being able to see this not only in 2D, but we can actually, by holding our center mouse key, we can flip this up and look around and see is this doing what we planned? Because we had a tab here that we were planning on having, right? Uh, well, this will tell us is our tab size right? You know what I mean? If we didn't see that tab where we put it, we would have a problem. If we were making one of these not go all the way through, we wouldn't want to see it going the full depth of everything else, right? So being able to spin things around in 3D when it's running, it's pretty good stuff. So we can always just click our top view here, the zoom to fit part, and it'll always go back to the top. So good to know here, being able to simulate, watch it, pay attention, and you can do this as many times as you need to before you start running it, so you're not wasting material and breaking bits, because this is a big thinking thing compared to plasma. You're not just going to jump into this after doing plasma and instantly be a master. Like I say, we're not even talking about feed speeds, different bit types, flute types, different materials, different coatings, different coolants, running air, the effects of vacuuming the dust and clearing your chips has, the temperatures in your shop, uh, the power of your spindle, how many RPMs is it going to lose, how much power does it have, did you do a spindle warm up to get your spindle warmed up so it's not having a wobble to it? All of these things affect it, and it's big time. So, and this here is just basic tool paths. We're not doing any adaptive. These There's going to be some load changes when it changes different direction on your bit, and you can't run this balls out on what the fastest part you could cut. You have to run it limited to what your slow speed is. So when you're going around a corner, your chips want to build up. That's what you've got to end up figuring on. Otherwise, you're going to have nothing but headaches breaking bits, and you're going to call your machine and me and the world and your piece of wood and your bit some really interesting names. It's- this is what it does. So we got all done. We can see this took 1900 seconds to do this. Okay, so we could divide that out and see, how many minutes are we going to spend on this, uh, and get a good idea. So just this little piece, right? This is only 6 inches by 6 inches. It's going to take almost 32 minutes to mill out, and we're not doing any tool changes. Uh, the way I had it laid out, I mean, really, we did do tool changes, but I didn't put that in for that, right? We just went in here and made our file different, but I didn't program for doing tool changes. So every one of these things that we did tool changes, we would have to set up one different, right? So maybe because we don't have a tool changer, maybe we don't want to do this with a 1/4 inch and do this one with a 1/4 inch, right? Maybe we just do this whole thing with an 1/8 inch bit. And or what we might want to do is put in our 1/4 inch bit, remove our big areas first, then put our 1/4 inch, touch off our Z again, set our Z, and then do the rest of it with our 1/8 inch bit. So you got to really do a lot more thinking with this. I know everybody's been wanting me to do milling videos, but this is why I don't, because it is so much more that goes into it. It's so much more complicated. And if you're not um, wanting to put that effort in and really get into it, but this is something that almost has to be a labor of love. You have to be passionate and want to know how to do this. Otherwise, learning it is gonna suck. You just have to, uh, want to be one with your machine and understand and be able to beat the system. You have to be able to, have that in you just to want to get the feel of things. So uh, you're gonna break bits. Don't think you're not going to break bits. You're going to break bits in the beginning. Trust me. Buy cheap bits in the beginning, learn it, figure it out. If you're trying to set up production, set it up with a cheap bit, then go to an expensive bit. Uh, get it dialed in with the cheap ones, because paying 60, 80, 100 plus dollars for a bit just to go in here and break something because you had a decimal point in the wrong spot, oh, you're having a bad day. Yeah, break 10 of those in a day, life sucks real quick. So these are all things you have to figure out. Um, Milling has a sweet spot, just like plasma does. If you're, plasma, if you're going too fast or too slow, you get dross. If you go too fast, you don't cut all the way through. If you're going too slow, you're losing arc stability and getting dross. Well, this is not much different. If you go too fast, you've got chatter. If you got too slow, you're cutting the same bits again, and yet again, your bit gets hot and breaks, or you've got chatter. So, uh, this is the same as plasma as far as the idea of it having a sweet spot and needing to learn it, learn how it sounds, learn how it feels. Because uh, honestly, when I'm running the machines, whether it be plasma or milling, the vast majority of whether I'm doing it right or not, I can tell by listening. You can hear you don't have airflow. You can hear that you know you're too high, or whatever it may be that you're doing with plasma. This is no different. If you hear chatter, or you hear it's not loading the thing. Well, other thing comes into play with milling is chip load. I'm not going to get too much into it, but you want to be cutting chips, not making dust. If you're making dust, you're burning bits up, and you're going to have really poor life and really crappy quality of cut. When you're actually cutting a sufficient size chip that can remove the heat in the chip, now you've got an effective system. So even wood, it doesn't really matter what you do. You really want to be cutting chips. So, and this is all variable between every type of material. If you're doing plastic, wood, aluminum, steel, all take a different bit, a different RPM, different amount of horsepowers, different everything, uh, different amount of flutes, different angle of flutes, different coatings. Some things require coolant. Some are better with just air. Some are better with nothing. It's 100% dependent on what you're doing and what you're making it out of. So understand that is a big learning curve. So But hopefully this video helped you guys. Um, Let me know what you think. Thanks.